Another 2 minutes will start.
सर
Yes.
सर वो राउंड रॉबिन स्केड्यूलर है सर, उसमें अगर हम लोग आईओ को इम्प्लीमेंट कर रहे कोड हिसाब से तो फिर सर वो आईओ को कैसे बनाएंगे, वो भी क्यों होगा, क्यों डेटा स्ट्रक्चर में स्टोर करेंगे उसको भी?
आईओ भी जो जाएगा वो क्यू में, लेकिन आईओ पैरेलल हो पाएगा, आप सोचिएगा।
हाँ हाँ,
The
वो हर
two
क्लॉक में वो
processes
होगा।
IO will be done parallelly. But as per the execution is concerned, it has to be go one by one, because you are considering CPU is only one.
Okay, sir.
Okay. So another 1 minute. So this week again, I planned for some quiz test. It may be this not this weekend, next week sometime. I'll tell you by tomorrow. I'll tell you. So at evening, somehow around 7:30 we'll conduct. Okay, the quiz test, and day after tomorrow possibly I'll give you the next assignment. The next assignment is related to the scheduling. Okay, scheduling, and one small assignment maybe from one synchronization implementation, because since you are going to implement the synchronization through C programming language in the lab classes, that's why I'm not more focusing on this. I'll just tell you how you can prepare a log or those kind of things. We'll going to study here, or how this P and V operation gets written, what you have to do, those kind of assignment will get, rather than how this producer consumer will be done, because the producer consumer problems, these things you have to do it in the lab. I hope so, once you learn this thread. But what is now covered in the lab?
Sir, one lab is done actually.
That bash scripting only, that
Yes.
before that for loop one, basics, that input output and stuff.
Still you are in the shell script, huh?
Shell scripting, yes, sir.
How many labs are conducted till now?
Sir, total 6, but effectively 2. I mean, we have submitted 1 lab.
Yes, sir.
Actively 2, total 6. What does it mean?
I mean, sir, first 2 labs, I mean, ma'am told about the shortcuts. I mean, the comments, 1 lab was not done. And then previous to previous lab, we were done the shell scripting. Previous lab, nothing was given. We were also doing shell scripting in the class.
So there's that practice one, not for evaluation.
Not for evaluation, yes.
Oh, okay. Okay. I'll look into it, what can be done. But this time the assignment will be little individual. Now you are comfortable with the group for how to do this. So this time you have to prepare individually and submit it. Okay. Because I hope so everybody has participated in the group. Those who have given the group, few people have submitted in their own. That's okay, no problem at all. But those who have given in the group, now you have to separately do it. Huh? Whatever the next assignment, I'll clearly write in the assignment. No problem.
Like a code it will be given, or like
no, again you have to modify in the expression.
Okay. Okay, sir.
Yes. But it will be interesting. I am planning to give some priority with round robin related some kind of algorithm.
Yes, sir.
How to implement that directly. Okay. So we'll start with today's class. Last class we have almost covered what is this producer consumer, and nicely the solution has given. So here it is observed that one producer, when it is multiple producer can be entered through this empty semaphore variable, which is a counting semaphore. And once the multiple person enter into the shop, only one person can touch this rack. And for touching the rack, we are using a same mutex. And last class also you discussed that is it a mutex and a mutex on? That is also not possible, because both of them are should be used a single lock. If you are using mutex and here it is mutex 1, means there is a possibility that one producer and one consumer at a time touch the rack, which is not allowed as per our requirement. Okay, and sometimes the question comes, can you write with respect to an array? Okay, so let's take there is an array and the array size may be given 0 to 9, where n is basically 10, and gradually the kexts will be put here, 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 and in the same manner the kexts will be eaten first year, second year, third year, fourth year, like this. The moment you give here, then give here, then give here, then give here, suppose 4 consumers have already it, means this side the 4 as empty, 4 rack spaces are empty. So when the next producer wants to keep it, you cannot say that I don't have a space. Rather, the producer has to keep it like this. Means we have to maintain a circular queue, and with the help of this, how to do this. The same style code, I'll just write a little bit different. So our requirement is one empty. So we have created a semaphore with empty will be basically n, and full will be basically initially 0, and we consider one mutex, which is nothing but so 1, because it is for the binary semaphore. And I have integer array. Yes, integer. Somebody 1744, could you please mute it? Okay, thank you. That is a int, then data, and this data having a n size data. Okay, and how to maintain this? So what you have to maintain here, when a person has to be kept here, the next has to be kept here, the next has to be kept here. So for keeping this data, I'll take a variable called as, let's take here p, and for receiving the data, I'll take here as s. So my s will be semaphore, it may be confusing, so we'll take a q. So p is for keeping the data, q is for receiving the data. Means when a producer wants to store the data, your p has to be plus plus. When a consumer will be eat the data, the consumer, you cannot say that sir, there are n data are present, the consumer can take from any rack. It is not allowed. So you have to take in FCFS special. So this q is meant for reading the data and for receiving the data, and p is meant for storing the data. And how you can do this? So I'll maintain one more p, which is becoming 0, and q, which is also becoming 0. Then what is the strategy? Strategy is our producer first produce, and the consumer has to be consumed. Before the producer goes, he has to be produce an item. So you can say that here get item. So get item or produce item, which is nothing but a int I, yes, itm, and this item has to be put it. For that you are making a pmt, whatever the code you have written last class. Then you have to make a pmutex, yes, then you have to make a vmutex, and inside this what you have to do, you have to keep the data. So how will basically you have to keep it? You have to simply write in this kind of code, that is a your data, this is data array of this p is equal to my itm, and p equal to p plus 1 modulus n. Correct? Is it satisfiable for the circular queue? Because yes, gradually p is incrementing. When the p reach here, this is 9 plus 1 modulus 10 will give you 0. Okay, so like this it is doing it, and after that you are making a v of a full. Similarly, this side you have to do it by directly making a p of full, then p of mutex, then you have to get the data. Get the data means I can take here that is int g item get item is equal to data of anybody can help me what I have to write.
Q.
Data of q, very nice, data of q, and
And then
similarly here
Q
q
plus
equal to q
mod.
plus 1 modulus max. Max here it is n. Okay, and similarly b mutex and p.
Sir,
Yes, please.
sir, here we will not check about that full condition.
We are checking now full condition. This full condition is checking directly by this now. When empty becomes 0, then it is automatically full. Yes or no? Because your initially empty was what? 10. Yes or no? Empty was 10. So gradually when first person enter, second person enter, third person enter, empty is gradually reducing or not? Because we studied in case of P it is reducing, B it is increasing. So when this empty value becomes 0, can your P allow anybody to enter into this place? No. So indirectly it is a full or not?
Yes, sir.
Okay, so that's why no need to write a condition, because the condition itself, whether it is equal to full or not, it is satisfied by the P operation. Very nice point. Others, have you understood what he has asked? He told that initially we are writing a condition that if count becomes n, then it is going to slip. But here there is no such condition how it is satisfying, because we have taken this empty is n, n means here 10. So as the first person, second person, gradually the producer are entering, then my empty value reducing, because P operation says that S equal to S minus 1. Whereas V operation says that S equal to S plus 1. So since my semaphore variable is reducing in the P operation, so when this empty value reach at 0, means already 10 processes have kept their cake inside this. In the same manner here also, since full is initially 0, you cannot enter. The moment the producer producing the item, when he comes out, he is making V full. Gradually the full gets increased as the items are produced and kept inside the rack. Once your full is increasing, means consumer can able to enter here because you have written P full. But at the very beginning, full is 0. Nobody can enter into this area if the producer has not entered. Okay, that is right. So this is this kind of question. One question we'll discuss.
For consumer, it will be last fee V and empty, because empty place increased by 1.
Be empty. Yes. Yeah, thanks. Okay, so this will be VMT, so that it will be matched with this one as you have last class studied, and this has to be matched with this. Okay, so in this one, and this two and this two are basically the same mutex lock that applied. Okay, this is fine. So next, a very interesting problem we are going to study, that is called as the reader writer problem. Okay, so what this reader writer basically says, as I have discussed, if there is any common area called as some a.txt, if many processes wants to read and few processes wants to write, so there may be many write processes, there may be many read processes. So how you are able to manage this a.txt, and what is the rule? The rule is basically, if there is a write with read is not possible, read with write not possible, read with read is possible, write with write is also not possible. So only one case is possible, other cases are not possible. So how we can manage it? So since I need a read operation and a write operation, assume that there is a function called as a read and there is a write. Yes, then how this reader writer can solve this issue? So first I'll go for the writer's place.
Sir.
Yes, please.
Sir, but if a file is being written simultaneously, we are reading it, sir, so it can also be taken place now, this operation.
No, both read operation can be taken place. No, that's why I have taken this. RR is possible. Any other options is not possible. Am I correct or anything wrong I'm saying?
Sir,
No
like
problem.
sir, like in a log files, there it is continuously written, and we are reading also.
No, when it is continuously written and reading, sometimes while writing there is a lock will be there.
Oh,
Okay, even if it is visible to you, but after updation you are getting this. One is a write through process is there in the cache, in the COA will study these things. Sometimes what will happen, it will keep close the writing, then read it, or sometimes what will happen that it will be continuing, and after that it will be save this data in the original file. Those part will become later. Okay, but
okay, sir.
initially very simple thing is that two readers can read it, or more than one reader can read it, but reader writer is not possible. That is the only criteria. So how the writer has to be done? Suppose I want to do a write operation. Participate, huh? Very, very interesting. If you want to write, can more than one write is possible?
No, sir.
No. So what kind of lock I have to put? Binary semaphore?
Mutex.
A mutex lock. Very nice. So somebody has told I'll put a mutex lock. So I can take a semaphore WR. Yes, is equal to 1. So I can put a P of WR and V of WR. Satisfied? Two write operation cannot be possible at a time. Is it sufficient? This is sufficient. I hope so. If you are not getting, please ask. Huh? Many situation comes in the book. Only they have given a one scenario. What is the solution that I am going to write? Obviously, same one. But there are many possible cases. They are going to ask if this is not P is not there. What is going to happen? If V is not there, what is going to happen? This kind of questions usually they ask. For that, your understanding is very important. The next, forget about now. Right, now comes to the read operation. So when you go for the read operation, I have to do the read here. Okay, this is my read operation and this is my write operation. While going for the read, I have to verify some place that whether he has a write or not. If somebody in the right, I cannot be allowed here. If somebody is in the nobody is in the right, then I can be allowed. Means you can say immediately, sir, before this read operation, I can also think of that if anybody is going for the right or not. Correct or not? Before I enter into this read operation, I have to verify if somebody is already in the right, this WR will not allow me to enter into this read operation. Correct? Sahi bola ki galat bola? If I'm just putting this W right here, can both reader and writer will be allowed here? Not.
No, sir.
If your reader is enter, a writer cannot enter because WR value will be goes to 0. If writer has entered, the reader cannot enter. So that condition at least satisfied. Means there is a WR, PWR must be before this reader. Now come to this. Suppose there is no writer present here. Then there are many readers are coming. Can this PWR has to be executed for everybody or it has to be executed for few persons? Suppose there is no writer present. Can this PWR needs to be executed or not to be executed? PWR.
Not needed.
Not needed. But he can make a safe side. If some readers are present here, guaranteed the writer should not be entered. Yes or no? If some readers are present here, I'm repeatedly saying, if you have doubt, you can ask. If some readers are present here, the writer should not be allowed. That's why he has keep a safe condition, that is PWR. But if I'm keeping PWR here, two readers cannot be allowed. Why? Because if the first reader has entered, then P becomes WR. So WR becomes 0. Then one reader R1 is present and R2 cannot enter while going to this. And what you need? Sir, PWR is necessary to avoid the writer should not enter while the reader is present. but this PWR is not required when the second reader is coming. Then what you can say? So this PWR is required for some reader and this PWR is not required for some other reader. Can anybody guess for which reader this PWR is necessary? For which readers this PWR is not necessary?
So for fast reader, PWR is necessary, right? Very
nice. For the first reader, it is necessary. For the second reader onwards, somehow this PWR has to be bypassed. Yes or no? If one reader is present here, I have to make this PWR to be bypassed by a R2 reader. That is the requirement. Then how can I bypass? As he told that if it is a fast reader, I have to do the PWR because it is necessary. But from the second onwards, I don't require. Then how can you identify whether I am a fast or second? Then what it does, why don't you take another variable called as a count? Okay. So if the count becomes 0, then when the first reader is coming, I can make here count plus plus. Then the count will be 1. When will be count is 1, you can say that the PWR is necessary. But if count is 2, 3 or something, sir, this PWR is not necessary. Then how can I identify? You can simply say that if, very nice,
count 0,
your count is equal to 1, then it is necessary, otherwise don't. Satisfied or not? अभी तक समझ में आ गया? मुझे I need a PWR, but this PWR is only required for the first reader. It does not require for the second reader if the reader has already entered. If the reader has already entered, then for second reader, it has to be skipped. So it is satisfied. Just see, when the first reader comes, count becomes 1. Count is equal to 1s. Then PWR executed, then WR goes to 0. If WR goes to 0, if any writer wants to enter, can he enter? He cannot enter because there is a reader exists. But when the second reader try to enter, count becomes 2 because count is a normal variable. This count becomes 2. If the count becomes 2, count is equal to 1, but count is 2. 2 is equal to 1 is false. False means it will be bypass this and come directly or not. So it is somehow working. Our principle is working. Now come for latter little bit. What is the second case comes? The second case is basically satisfying that when you have to come out. So when you will come out, I have to come out. So while I have to come out, I have to tell to the writer to write. Then can anybody tell me if there is a n readers are currently present in the read section, this section, in which scenario this writer will be allowed? Yes, please tell me. If the 10 readers or 5 readers are present inside this read section, when the writer will be allowed to do this?
Sir, when the last reader has left.
When all the readers will be removed?
Yes.
Yes, sir.
Yes or no? When all the readers become removed, then it is become allowed. Now you can say, sir, how can you know that it is
Count minus minus.
No. When they are removing, why don't you make a count minus minus? So that if there is a 3 readers present, count becomes 3. When one by one they are removing, then count is goes to 2, count is goes to 1, count is goes to 0. The moment the count becomes 0, that fellow has to be told to this writer that you please write. And how will you tell? By making
of WR
to be 1 or not. Yes? Which place? The last one. How can you identify the last one? If our count is equal to 0, then you can say V of
WR.
Yes. So once you do this much, our job is over, almost over. But there are many issues. We'll come to that point. Yes. So what is the point? Very nicely it is written. That is WR has to be maintained by a PWR and VWR. And this read has to be maintained by also PWR and VWR. So reader and writer both are not allowed at the same time. But what is the strategy they are maintaining? There is a possibility of a multiple readers to be entered. Since there is a possibility, he is saying this PWR has to be executed for the first person and this will not executed for the rest of the persons. Similarly, when the readers are going to be come out, when nobody is present. So when nobody is present means what? The count is reached at a 0. Then that time I have to tell to the writer that you may go inside and do your work. Okay, you may go inside and do the work. Then what should the approach? The approach is very simple here. This count is incremented, count 1, then do this. Count is decremented, count 0, then do this. But one observation, one flaw is that. What is the flaw? Let's assume, because it is a normal code. It is not like any log kind of code. It is a normal C code. You think in this way, and it is executed. When this both two readers are going to execute this read function, because it is a function, you can assume that it is basically a function, reader function. When this reader function is going to be executed by two processes, that is P1 and P2, there is a chances of context switching. And when the context switching occurs, let's assume the context switching is occurred at this place. Then what happens? The first reader enter and check that count is 1. Are you getting my point? The first reader enter, check that the count becomes 1. Yes, he has made the count to be 1. After that, the context switching is happening. When the context switching is happening, there may be a writer, there may be another reader. If a writer is coming, he may enter here. We are not considering now a lot about this. But if another reader is coming, you can just verify this reader will be make the count to be 2. This count to be 2. When this is become count to be 2, then what will be happening?
Lock is not applied.
This particular if condition is false for both the cases. Since it is made for both the cases, both of them will be skip this area. Since both of them will be skip this area, then what is going to happen? That is basically 1 minute. Just hold on. Yes, sorry. If this count is become 2 or more than 2, then both the person will be skipped. When both the person will be skipped, this P write is not executed. If P write is not executed, WR still 1. Then both of them are present here. R1 will be present, R2 may be present here. If both will be present, that time if a writer wants to enter into this, the writer can easily enter because the WR still is 1. Since WR is 1, then it is make it 0 and writer can able. Yes.
Sir, here can we add another condition for the writer one that count should be 0?
Count should be 0. That is one. But very easy condition is that because of this context switching, everything is creating a problem. Then why don't you block this context switching? Now, how can you block this context switching? Very simple way, that this area should be entry by only one process. Then for that, how one process can enter only? I can apply one more variable mutex. So if I'll apply here p mutex and there is a v mutex, then there is no issue. Why? Because only one process enter, he will be executed, count will be 1. Unless until he will be come out, then another process cannot enter into this particular area. So that is one interesting features they have applied it here. Okay, one more interesting thing. Can you, anybody thought about that? Is there any mutex is necessary here or not required? Tell me a condition.
Sir, it is required because if two processes are simultaneously decrementing, like if it is 2 and two processes will decrement, first 1, then 0,
Huh?
then another one will come and decrement further to -1.
Okay.
It
Then
could
what
cause problems.
No. What is the problem? What is the problem then? Problem you have to tell me. What is the problem exactly you have to tell me? Anybody else? Not only the same person. I'm saying if I'll not put here p mutex, here I put because I told what is the issue. Suppose I'll not put this p mutex here. What is the issue? Others? Participate. नहीं तो आप सुन नहीं रहे हो, बस जो बोल रहा हूं आप ऐसे रट के जा रहे हो. What will be the issue if I'll not write a p mutex and v mutex here?
नहीं सर, कोई इशू नहीं होगा.
कोई इशू नहीं होगा. Anybody else? मत सोचिए कि मैं पूछ रहा हूं मतलब इश्यूज है.
क्योंकि काउंट ऐसे भी वो 0 तक ही जाएगा क्योंकि उतना ही रीडर है.
Okay, fine. Anybody tell me? Yes. What happened? सब लोग हो या नहीं हो? जब क्वेश्चन पूछता हूं तो चुप रह जाते हो.
Sir, can you please re-explain the why p mutex is there? I mean, how it is resolving the context switching ambiguity?
Obviously, this is simplest case is that when it is a p mutex, mutex is 1.
Yes.
Can your p mutex allow more than one person to enter in this area at a time?
No.
No. If not, then what happens? Only one process enter, make the count to be 1. Initially count is 0, make the count to be 1. And he is present here. Even if the context switching is happening here, can your P2 is allowed to enter into this area?
No. Okay.
No. If not, then what happens here? Definitely this P1 process has to be go through this lock.
Yes.
Yes or no? If P1 process go through this lock, and you assume that the WR has to be changed to 0, so another writer or another reader cannot be entered.
But sir, here when context switching is happening, let's say P1 is here at after count plus. Then after that our process is entering through writer.
Fine.
Then process entered through writer, it can do write.
Right. Yes.
Then the process comes through count equals to 1, then P write becomes 0.
But P write becomes 0, so he will stop there.
Okay.
Because the writer has entered, make the WR to be 0. Even if the first process is coming here, the WR is become 0. Can he cross this line? He cannot.
Okay.
Currently inside the if, he cannot. Okay. So similarly, I'm asking, is there any P mutex and V mutex is necessary or not? Think.
Sir, but you said that it is not necessary.
No, I told that if I'm asking means you don't think that it is necessary.
Sir, I think sir, it is necessary because context switching can occur after count -9.
Very nice. Then I'm asking, what is the problem? That only I asked to Dipankar. What is the problem exactly of it? Otherwise मजा नहीं है. जैसे मैं आपको यहाँ बताया.
Sir, then again count will be subtracted, so count should become -1.
Count will not reach at -1. How the count will be reach at -1? You have to tell me.
Sir, again, if context switching occurs after count -1.
Count कभी count 0 होगा या suppose there are two processes. Now you can think. I am giving you a hint. Suppose there are R1 and R2 two processes are present currently. I have not given a P mutex. सब लोग सोचिए क्या problem हो सकता है. Hint दिया. R1 and R2 दोनों यहाँ पर है. अगर दोनों यहाँ पर है, काउंट कितना होगा बोलिए?
0 हो जाएगा.
नहीं, यहाँ पर काउंट 2. वेरी नाइस. काउंट 2 होगा. अभी सोचिए कि if in this area the context switching is happening, what is the problem? बता पाओगे आप? आता है आप? थोड़ा सा सोचिए, वो हिंट दे दिया हूं, और ज्यादा हिंट देने से सॉल्यूशन बता दिया. नो, यू आर ऑल ब्रिलियंट.
सर एक के लिए तो वो काउंट 0 हो जाएगा, तब
हाँ?
तो वो लॉक अनलॉक कर देगा.
हाँ?
और एक के लिए तो मैटर भी नहीं करता ना.
नहीं मैटर करता है, बहुत मैटर करता है, बहुत मैटर करता है.
ओ
तो
हाँ,
आप
तब तो
आगे
वो
नहीं
फिर
सोच रहे.
काउंट 1 हो जा रहा, फिर सिर्फ 1 तक जाएगा उसका.
नहीं, काउंट अभी यहाँ कॉन्टेक्स्ट स्विचिंग होने पर और
ओ हाँ
लास्ट.
हाँ हाँ सर, वो दोनों प्रोसेस के लिए कॉन्टेक्स्ट स्विचिंग हो जाएगा, फिर वो वाला वी ऑफ डब्ल्यू आर
हाँ,
दोनों के लिए होगा.
दैट इज द पॉइंट. हे, होने से क्या होगा?
दोनों से 2 बार 1 होगा वो, फिर डब्ल्यू
नो
आर
नो नो
प्लस
नो.
प्लस प्लस प्लस
हाँ, वो कितना हो जाएगा डब्ल्यू आर फिर?
2.
2. If it is 2, can 2 writers will be enter easily or not?
यस सर.
Are you getting what he has told? He told that if count is 2, suppose the R1 comes out. When the R1 comes out, then what is the value of count now? 1? Yes or no? Then context switching is happening. Again, R2 try to come out. So he will execute this because context switching has happened. So this will be goes to what? 0. Now count becomes 0. When the count becomes 0, this line will be executed by R1 and R2 both. For the both, it is a true statement or false? True. If it is becoming true, then V write will be executed how many times? 2 times. What is the WR's value since R1 and R2 present here? WR, they must have crossed through this WR. What should be the WR
0.
value? 0. If V of WR will be run 2 times, then the WR value reach at what? 2 or not? Because we know V of WR is nothing but a WR plus plus. So how many times this WR plus plus will be executed? 2 times. If it is 2 times, then what is my WR's value? 2. If it is becoming 2, how many processes will be allowed here to enter into this area? If WR becomes 2, binary semaphore padhe the, that is 2. So which is not acceptable.
Sir, I have one doubt here. After count minus minus for R1, count becoming 1, then context switching is happening. Sir, I mean, what is happening during context switching? That
during the context switching, the CPU is changes from R1 to R2.
Okay. R1 to R2.
R2 has also finished its read operation. He wants to come out. When you will come out, he again executes this count minus minus. So count is now reached to 0. If it is 0, both of them are here. R1 and R2, both of them are here. When they will execute this line, this is true for both. If
both,
it is
yes, two multiple writers.
Yes. And we know inside your V write there is no such condition. Only we have studied S plus plus or S equal to S plus 1. So my WR is now increased to 2. If it is becoming 2, then 2 process enter. That's why I thought, why don't you make here P mutex and V mutex? Understood? Yes. So by this way, it is now somehow proper. Yes. Now it changed a little bit. If you have little understood. Yes. So what you have to do? Let's assume I change it to mutex 1, but it is mutex. Can it will work? अगर क्वेश्चन ऐसे आ गया, कोई एक कोड दे दिया, ऐसे पूछा कि व्हाट इज द प्रॉब्लम इन दिस सिनेरियो, इन दिस कोड,
तो सही होगा.
सही होगा?
हाँ सर, इंडिपेंडेंट है.
यस सर, वर्क करेगा.
कोई बोल रहा है सही होगा. वेरी नाइस. हाँ, और बोलिए, सोच के बोलिए, नहीं तो खुद को वहां पर घर में बैठ के थप्पड़ मारिए. यस, प्लीज डोंट टेक इट अदर वे. हाँ, मजाक से बोल रहा हूँ. फिर भी थप्पड़ मारना चाहिए. टेल मी व्हाट इज द प्रॉब्लम. अगर ये बता दिया, मैं समझ लूंगा कि आप रियली सीख रहे हो. सोचिए 10 मार्क का क्वेश्चन आ गया है. व्हाट यू शुड राइट. देखिए, सिंक्रोनाइजेशन में नंबर ऑफ लाइंस आप आंसर दोगे वेरी फ्यू. but it will be 10 out of 10. It may be 1 line, 2 line answer, but the whole thing will be a long question. जैसे हम यहाँ पर बताए थे, याद है? The last class, I'll change it to mutex 1, mutex
Yes, sir.
1. You told that no, sir, it is not correct. Similarly, you think here, if I'll take a different mutex and a different mutex here, whether it will work or not work.
सर अगर डिफरेंट होगा तो काउंट प्लस प्लस और काउंट माइनस माइनस एक साथ होने का चांस होगा सर?
होने का चांसेस है, वो एक इनकंसिस्टेंसी आएगा. अब बोलोगे yes or no?
यस
You
सर.
tell that there is a possibility of inconsistency, that I accept. One view. Another view. Suppose inconsistency नहीं आता है, सोच लीजिए कि काउंट अगर प्लस प्लस हो रहा है, एक बढ़ रहा है, काउंट माइनस माइनस हो रहा है, एक बढ़ रहा है. एंड सोच लीजिए दिस काउंट प्लस प्लस एंड काउंट माइनस माइनस इज ए सिंगल इंस्ट्रक्शन. तो कभी भी उसका मिडिल में कॉन्टेक्स्ट स्विचिंग नहीं होगा. ये सुनो, काउंट प्लस प्लस एंड काउंट माइनस माइनस का मिडिल में कॉन्टेक्स्ट स्विचिंग होगा क्या? काउंट प्लस प्लस पूरा एग्जीक्यूट हो जाएगा, देन द काउंट माइनस माइनस विल बी एग्जीक्यूटेड, और काउंट माइनस माइनस विल बी executed first, then count plus plus. Then you can say there will be no issue.
सर काउंट प्लस प्लस और काउंट माइनस माइनस अगर सिंगल इंस्ट्रक्शन रहता तो सर म्यूटेक्स का मतलब जरूरत नहीं होता ना सर?
काउंट प्लस प्लस और काउंट माइनस माइनस, फिर से थोड़ा आंसर चाहता हूँ
सर. अगर सिंगल इंस्ट्रक्शन होता सर तो फिर तो सर म्यूटेक्स का यूज ही नहीं होता ना सर?
नो, द सिंगल इंस्ट्रक्शन में क्यों बताया ना म्यूटेक्स का यूज है? क्यों यूज है? देखिए, even if it is a count plus plus is a single instruction, but after this single instruction gets executed, another reader comes here. It is a single instruction. Think that it is a INC count. INC stand for increment, DEC stand for decrement. If it is a single instruction, then also issue is there or not?
Yes sir, there sir.
It is there. So that is not the answer. Anybody else?
हाँ सर. सर तो फिर अगर एक प्रोसेस अगर खत्म हो गया, मतलब वो काउंट माइनस माइनस स्टेज में, और एक प्रोसेस अगर एंटर हो रहा है, तो सर वो उस सिचुएशन में सर वो म्यूटेक्स और म्यूटेक्स दोनों सेम होना चाहिए, क्योंकि फिर अगर हम लोग डिफरेंट रखते हैं तो फिर इनकंसिस्टेंसी ऐसे हो सकता है.
सपोज एक R1 है, सो दैट सब लोग हम समझ पाएंगे ना. सपोज सोचिए कि एक R1 है, क्या होगा बोलिए अभी?
यहाँ पे R1 माइनस माइनस हो गया,
हो गया, तो काउंट 0. am I करेक्ट?
नहीं, यहीं पे कॉन्टेक्स्ट स्विचिंग होगा, और एक प्रोसेस जो अभी रीड करना चाह रहा है. नहीं,
काउंट से पहले या काउंट के बाद कॉन्टेक्स्ट स्विचिंग?
काउंट के बाद.
काउंट के बाद हुआ तो काउंट 0 हो गया कि नहीं? हुआ ना, क्योंकि R1 अकेले था, R1 was alone present, means count was 1. correct or not?
नहीं सर, मैं बोल रहा हूँ कि वो काउंट माइनस हुआ, उसके बाद ही वो कॉन्टेक्स्ट स्विचिंग होगा.
मैं मान रहा हूँ, मैं बस बोल रहा हूँ कि जब काउंट माइनस माइनस हुआ, काउंट का वैल्यू कितना होगा वो मैं पूछ.
0 हो जाएगा.
0 हो जाएगा. फिर कॉन्टेक्स्ट स्विचिंग हुआ, फिर बोलिए.
फिर सर वो और एक प्रोसेस P2 वो भी शुरू से रीड करना शुरू करेगा.
Fine.
तो इसमें भी म्यूटेक्स तो दोनों अलग है, तो ये एंटर कर जाएगा.
वेरी नाइस.
इसमें फिर वो 1 हो जाएगा, अभी 0 से 1 हो गया.
वेरी नाइस.
यहाँ पे वो
तो अभी 1 हो गया, 1 हो गया. हाँ,
फिर से अलाउ कर देगा अभी, मतलब लॉक कर देगा. लॉक कर दिया और फिर इधर आ गया, और फिर से कॉन्टेक्स्ट स्विचिंग होगा वापस.
यहाँ पे कॉन्टेक्स्ट स्विचिंग हो गया. ओके, यहाँ पर कॉन्टेक्स्ट स्विचिंग हो गया. फिर
लेकिन इसमें अभी वो अनलॉक नहीं कर पाएगा, फिर वो 0 नहीं है.
इट हैज बिकम 1, देन ही हैज कम आउट.
यस सर,
he has come out nicely. What is the problem then? Because you told that this count is 1 now. If count is becoming 1, then what happens here? Then he is coming out. He is easily skip this and come out. What is the issue? क्या होगा? Okay, this is the question for all of you. For day after tomorrow we have a class. For all of you, this is the ones. Once you know these things, your reader writer problem gets over. If you can understand this. And next class again, based on this question, I'll ask you one more question. Okay, but you have to tell me in the next class if there is a mutex and a mutex 1, exactly tell me a scenario where the problem is occur. Okay, yes, you think and tell me. So I hope if I am making a mutex and a mutex, that code you understood, everybody, how it is entering, how it is come out, and why you are writing count is 0 to WR and a count is this to WR1. So that you have understood. Now my question, next question, if I change this mutex here and change to mutex 1, then what is the issue? So by this way, you can understand the reader writer. And after you answer that one, again I'll ask one more question based on this reader writer. Okay, so we'll go to the next problem, that is classical problem, is called as a dining philosopher problem. Okay, this is called as dining.
सर ये सब प्रॉब्लम मैथमेटिक्स है या फिर मतलब ये कंप्यूटर साइंस का कुछ है ये प्रॉब्लम?
All problems are computational. You have to write these things in your code.
तो मतलब वो जो स्टेटमेंट है फ्रेम वाला, ये जो स्टेटमेंट है इस प्रॉब्लम का, वो
अभी जो पूछा मैं, what is the mutex and mutex 1? Oh, that you have to normally write. If it is the case, if you can maintain a line 1, line 2, line 3, you can say that after which line the context switching is happening by which process, then what is the count and what is the problem.
Okay sir.
Okay, one question एक बार आया था क्वेश्चन, इसलिए मैं पूछ रहा हूँ. बस एक बार डाले थे मैं, कुछ एक दो बंदे कर पाए और नहीं कर पाए. That's why I'm asking you that whether you are now learning, whether you are able to do it or not. Yes, because question paper will be prepared by somebody. I also don't know. So if in his mind he is able to answer, give this question, you should be eligible to answer this. Otherwise, maja nahi hai. Yes. So what is a dining philosopher problem? The dining philosopher is very simple. That is a dining table. Yes. There are 5 philosophers are sitting here. So one is this philosopher, one is this philosopher, one is this third philosopher, this is the fourth philosopher, and this is the fifth philosopher. These are the philosophers. They are sitting. And what is the each philosopher's one? Assume that this is a P0 philosopher, P1 philosopher, P2, and P3, and P4. So there are total 5 philosophers are sitting. And what is the work? The work is very simple of each philosopher, that he has to be think, eat, and think. So thinking, eating, and again thinking. So this process repeated. So they are not sleeping anything, just thinking. Before eating, you can think that he is hungry, then eating, then again he is going for the thinking. So the process is simple: think, hungry, eat, and again think. So each philosopher's work is this much. You can remove this in the book. This may not be written. They will written that think, eat, and again think, and so how they're thinking, how they're eating, thinking is in their mind, in their own mind, but eating has a certain criteria. On the front of each philosopher, there is a bowl where the food is present. Okay, so there is individual bowl. So each one have their independent bowl. So there is no issue. Why? You can say, sir, till now, whatever you have told, all are become independent process. Why? He is thinking, eating from here, thinking, eating from here. So he is not disturbing him also, because he is also eating from his bowl and thinking. His bowl, thinking. So there is no issue of synchronization here. So how the synchronization comes? But when they are eating with spoons or chopsticks, जो हम बोलते हैं. लेकिन कितना chopsticks है? There are only 5 number of chopsticks are available. Okay, 5 number of bowls are there, but 5 number of chopsticks are also there. Yes, but how they will eat? One person can eat only if he has 2 bowls. If he has a left chopsticks, Chinese fellow. He has a left chopsticks and right chopsticks, then only he can eat the this Maggie or something, he can eat it. Now, since you have a 5, this all 5% cannot eat at a time, because you have total 5 spoons, and to eat a single philosopher I need 2. So maximum how many philosophers can eat? 2 philosophers, not more than this. Yes, are you getting my point? You have only one simple one bowls for each philosopher, but there are only 5 spoons, and everybody has a left spoon and a right spoon. And how they are numbering? Assume that this spoon is numbering by a S0, this is S1, this is S2, and this is S3, and this is S4. Now they are asking how this 5 philosophers can eat and think without making any fighting with each other. Yes, they are very genuine persons. What way you have to write the code that who will take the chopsticks when, so that they will not fight. But you are very sure that 5% cannot eat, even if 4% cannot eat, even if 3% cannot eat at a time, only maximum 2, because 2% के लिए 4 chopsticks चाहिए, and 1 will be left out. That's okay, but more than this cannot be allowed to do this. Then what is the solution they're asking? Okay, so let's see how you can think. The problem may not be same. The problem may be think in a different way. Now tell me which part of this figure is need to be synchronized and which part is not need to be synchronized. If you can look into it, these bowls are, if each of them are individual resources, then the bowls are not to be synchronized. Not to be synchronized, because each of them have their individual bowl and they are taking from them. Means it is independent to each other. Only the problem is this S0, S1, S2, S3, and S4 is basically the dependent resources. Dependent resources means what? Or shared resources. Why it is a shared resources? Because this fellow is also using S0 and P4 is also using S0. And we have studied, if there is no sharing and no simultaneously, then there is no question of inconsistency. Since there is a possibility of both P4 and P0 is going to eat at a time, and S0 is the shared resources which has to be taken by both of them, that's why there is a need of synchronization. Everybody got it? Why there is a need of synchronization for S0? Because S0 is my shareable resources, P4 and P0 need these resources, and P4 and P0 may want to eat at the same point of time. So that's why there is a question of synchronizing this S0, P0, P4, P1, P2, P3 for this resources called as S0, S1, S2, S3. Now how to do it? So very simple approach. Which kind of resources? I can say S0 is one resource which can be accessed by only one fellow at a time. If S0 will be accessed by one fellow at a time, definitely I have to put a log kind of things for S0. I cannot put a normal counting semaphore for S0, because S0 will be accessed by only one person at a time. Then what they thought? For each S0, S1, S2, S3, S4, the same rule has to be applied. So what they thought, why don't you create a semaphore of array of semaphore, that is S of 5, which is initialized with 1, 1, 1, 1. Okay, so there are 5 semaphore variables, and each semaphore variable should be assigned with 1. Then how a process can eat? So the process work is like this. If you can say it is a philosopher's work. Which philosopher? You can take a integer ith philosopher. And what he is going to do? He is doing a repeated work. Infinite. Yes, he is doing some infinite work. Now you can understand what to write. Infinite work, because this loop is infinite. What they are doing? Eating, thinking like this. So they will think, then eat, then think, then eat like this. So I know I have to think, I have to eat. Ready? Somehow it is ready. Ith process comes, he is in a loop, thinking, eating, thinking, eating. Another ith process comes, 1th process comes, he is thinking, eating, thinking, eating, like this. Now thinking is not creating any problem because everybody has their own individual mind and they are thinking with this, and that is completely independent. But eating requires a spoon. Since they requires a spoon, now if you can look into it, this particular figure, for P0, if I becomes 0, he needs 0th spoon and 1th spoon. Yes or no? He needs 0th spoon. If I is 0, then he needs 0th spoon, 1th spoon. If I is 1, he needs 1th spoon, 2th spoon. If it is 2, then 2th spoon and 3th spoon. If it is 3, then 3th spoon, 4th spoon. If it is 4, then you can say I need some 4th spoon and 0th spoon. Then what is that? For ith process, he needs some ith spoon. And what is this? Guess? What should be this spoon number as per
I plus 1 mod that 4.
5. Yes or no?
5.
This is becoming my I, and this is nothing but a I plus 1 modulus 5 or not. Yes or no? Then every ith process needs this 2 spoon. Since I make this spoon to be semaphore variables, then I can say one ith process can eat provided ith spoon and I plus 1 modulus 5 spoons are available. Correct or not? This ith process can eat provided his ith spoon and I plus 1th spoon is available. But what you have set, sir, you have set for 0th spoon, you have set 1. For 1th spoon, you have set 1. 2th spoon, 3th spoon, 4th spoon. For each individual spoons, you have assigned this 1, 1, 1, 1 semaphore. Then can you say, I'll check some
0.
2 semaphores, then I'll allow to enter?
Yes, sir.
Yes or no? Then which semaphore it should be? Anybody? And it should be?
Sir, we can combine it.
First I'll write 1, then we'll go for the problems here. So what he does, he is making say that if ith process wants to eat, first you have to check the S of I semaphore. If it is free, check that S I plus 1 modulus 5 semaphore. If both of them become free, then he can only come here. Because if only one is free, this is not free, your process is still waiting here. But if it is free and this is also free, then he can able to allow to enter. Then what they are basically doing? This fellow is reducing 1 to 0 and this fellow is reducing another 1 to 0. But what is after it? Can this spoon's semaphore will be still 0, or you will allow the spoon to be taken by your neighbors?
Allow.
How can you allow then? Because you have made this to 0. So if you want to allow, you can simply say that B of S of I and B of S of I plus 1 modulus 5.
So the order here matters.
It doesn't matter a lot for this moment. It doesn't matter because I'll release this and I'll release this. Yes. So if I do like this, somehow you can find my dynamic philosopher's problem is little bit sort out. Why? Because it is a loop where I'm thinking and eating. This is thinking and eating. But before eating, I need 2 spoons. Since each spoon is only 1 unit, for every 1 unit, I have kept here a semaphore for that spoon. If semaphore value is 1 for that spoon, then I will be allowed to the next step. If my right spoon is also semaphore variable is 1, then I will be allowed to eat. Means my left spoon should be free, a right spoon should be free, then I allowed to be eat. Once it will be allowed to the eat, then again you have to release the spoon, because after you are eating, my next person has to be eat. So how they are allowing? Here it is allowing by V operation. So this is the simplest solution to do it. But there is an issue. What is the issue? Last. I'll stop. Last point. What is the issue? Can anybody think in this? Few seconds I'll ask. Issue means always you think context switching, because it is a code. Everybody is running this code. P1 running, P2 running, P3 running, P4 running, P0 running. Can anybody tell me what is the issue will come? Where the context switching will happen, like I have asked in the previous case. Quick. Here, is there any issue? Think के बाद
नहीं सर,
नहीं, because think किया तो उसके बाद खाने के लिए जाएगा. Here, is there any issue?
नो सर.
No. Anybody else? No? Very interesting issue here. Let's say each process has tried to enter into this area for eating. Everybody was thinking, and at the same time they want to eat. And first process enter here and make a context switching after P. Second process enter, third process enter, fourth process enter, and fifth process enter. If P0 is entering, make a context switching. P1 is entering, make a context switching. Then what happens? This P0 occupy this one. This P1 occupy this one. This P2 occupy this one. This P3 is
Yes,
occupying this
nobody
one.
will be able to.
P0 is occupying this one. Then what happens? Everybody has taken their left chopsticks, and for them there is no right chopsticks is available. Agreed or not?
Yes, sir.
Yes. If this the context switching is happening exactly upon this P line, means everybody have taken their left chopsticks and make their SO for I to be 0, because previously it was 1, now it is comes to 0. If it is becoming 0, then they could not execute this line, because their right chopsticks will be taken by their right neighbor, and he is also holding and he is also requesting for his right chopsticks. वो भी उसका neighbor ले लिया है. So कोई छोड़ने के लिए राजी नहीं है, and nobody wants to give up, because भूख लग रहा है, hungry भी है, think भी नहीं कर पाएंगे. Think कब करेंगे? यहाँ से आके यहाँ आएंगे तो think करेंगे, but यहाँ तो फंस गए. Then this scenario is called as a deadlock scenario. Means nobody is going to progress further. That is basically a deadlock scenario. जैसे हम लोग सीखे थे, अगर चारों तरफ गाड़ी आ रहा है, अगर एक जगह पर रुक गए, then neither he can move or another 3 people can move. So
सर म्यूटेक्स लगा देंगे उधर.
So क्या लगाएंगे नेक्स्ट क्लास पर, ठीक है ना? But my question, it is very simple question, but my question, everybody please think. If you are really studying, please think in your own and try to identify different scenario. Yes, let's say next sometimes, because in some sections they are also doing, I'll ask to independent people, if they are telling, then some 1 mark or 2 mark will be assigned. In some other class, some questions will be asked. Let's do in that way. Huh? Okay, I'm ending now. That's all.
Sir, this recording please upload it in the Moodle, sir.
Okay, sure.